So in this video we're going to revise how to calculate the concentration in moles per dm cubed. The main equation we're going to need is concentration is the moles divided by the volume in dm cubed. So when we put that into a triangle, moles goes at the top and we have concentration and volume underneath. That means if we want to work out the moles, it's going to be concentration times volume. And once again, I can't stress enough how much we need to realise the volume is in dm cubed. So to change from cm cubed to dm cubed, you divide by 1000. So 200 cm cubed, once we divide by 1000, would be 0.2 dm cubed. Let's look at some example questions. Calculate the concentration of a solution made from 100 grams of sodium chloride dissolved in 3 decimeters cubed of water. So the equation we use is concentration equals moles divided by volume in dm cubed. So first of all we need to work out the moles, and we remember from previous videos moles equals mass over mR. So the mass of sodium chloride is 100, so therefore we need to work out the mR, and sodium has a mass of 23 and the chlorine part is 35.5, so that comes to 58.5. We put this in the equation up here, and 100 divided by 58.5 is 1.71 moles, which we can then put into the equation over here. So concentration is the moles, which is 1.71, divided by the volume in dm cubed, which is 3 dm cubed, and that comes to 0.57, and the unit, because we've got a moles divided by a dm cubed, the unit is going to be in moles per dm cubed. So that is our final answer. On the next question, we need to spot that it says calculate the concentration of a solution made from 50 grams of glucose dissolved in 650 cm cubed of water. So we need to spot straight away that it is in cm cubed, so it's going to add another step to the calculation. But once again we start off with concentration equals moles divided by volume in dm cubed. That means the moles is mass over mR. So we need to work out the mR of glucose. So that's going to be 6 times 12 for the 6 carbon atoms, plus 12 times 1 for the 12 hydrogens, plus 6 times 16 for the 6 oxygens, and that comes to 180. So the mass is 50 grams divided by 180. The number of moles of glucose we've got is therefore 0.27 recurring moles. So we come back to this equation. Concentration is moles divided by volume in dm cubed. We now know we've got 0.27 recurring moles divided by, so we're going to need the volume in dm cubed, so we do 650 divided by 1000, which is 0.65 dm cubed. So we'll put 0.65 here, and that comes out at 0.43 moles per dm cubed. That could be slightly different if you rounded up at this stage to 0.28 divided by 0.65, or whether you kept it as 0.27 in your calculator. Now in question 3 it says calculate the mass of zinc sulfate needed to be added to 2.4 dm cubed of water to make a solution with the concentration of 0.5 mole per dm cubed. So we've got the volume and we've got the concentration. So we're going to need to work out the moles first and then we can work out the mass. So this time we use moles equals mass, moles equals concentration times volume. So that is going to be 0.5 is the concentration times the volume, which is 2.4 dm cubed, and that comes to 1.2 moles. So we need to dissolve 1.2 moles of the zinc sulfate in that amount of water, but it's asking for a mass. So we need to remember mass equals moles times mR, which is 1.2 times the mR of zinc sulfate. So first of all we need to work out the mR of zinc sulfate, and that is 65 for zinc plus 32 for the sulfur plus 4 times 16 for the oxygen, and that comes out at 161. So we put that in up here. Mass is moles times mR, so it's 1.2 times 161, which is 193.2 grams. Okay, time to try some questions for yourself now. So read each question carefully, pause the video and then check back in to see how you got on. So on question 1, once again we start off with concentration equals moles over volume in dm cubed, which is, well, we need to work out the moles because we don't know the moles yet. So we do moles equals mass over mR, which is 400 divided by the mR of potassium hydroxide is 39 for potassium plus 16 for oxygen plus 1 for hydrogen, which comes to 56. So coming back to this equation here, moles is mass over mR, which is 400 over 56, and that is 7.14 moles. So the concentration is moles over volume in dm cubed. So we now know the moles is 7.14. In the question it's already in dm cubed, so we can just use the 2.2, and that comes to 3.25 moles per dm cubed. Well done if you got that correct. Question 2. Have a go at question 2 and then check back in with the video when you've tried it. So on this one, straight away alarm bells should be ringing that we've got the volume in cm cubed, so we're going to need to convert that at some point. So once again we've got concentration is moles divided by volume in dm cubed. So the first stage is to work out the moles, which is moles is mass over mR, which is 350 divided by the mR of copper chloride. So the mR of copper chloride is going to be 63.5 for the copper plus 2 lots of 35.5 for the 2 chlorine atoms, and that comes to 134.5, which we put in up here. Okay, so still working out the moles. 350 divided by 134.5 is 2.6 moles. So we now put that back into our equation. Concentration is the moles, which is 2.6, divided by the volume in dm cubed. So first of all we need to take the 450 and divide it by 1000, and we get 0.45 dm cubed. And when we do 2.6 divided by 0.45, we get 5.7 recurring, and it's going to be moles per dm cubed because we've got a moles divided by a dm cubed. So that would be our answer to that one. Question 3 is quite a challenging question. Even if you don't get the final answer right, remember if you showed you working out, you can pick up marks along the way. So have a go, pause the video and then check back in when you've done it. On this question, it's asking for the mass of lithium chloride, the solute. So first we need to work out the moles of it. So moles is the concentration times volume in dm cubed, which is 0.75 times 1.7, and that comes to 1.275 moles. But we want to know the mass needed. So mass equals moles times mR, which is 1.275 for the moles, times the mR of lithium chloride. Well, lithium is 7 and chloride is 35.5, so that's going to be 1.275 the moles times 42.5 is what the mR works out at for lithium chloride, and the answer we get is 54.2 grams. So very well done anybody who got that one correct.